Hello and welcome to another Solana tutorial. This is a continuation video of the previous video where we talked about the setLoadedAccountsDataSizeLimit of the compute budget program, and we said that it would increase priority, but we didn't prove that it increases priority. So that's what we're up to in this video. And in order to do so, I'm gonna create myself my own little program once again, because we saw that testing it on mainnet, even with the lowest possible priority, my transactions just land. So my idea is now I will make a simple counter program that counts successful transactions, and then I will just call a bunch of transactions on two different counters, one where I set the loaded accounts data size limit and one where I don't, and then we compare if one of them will have fewer successful transactions. That's the plan. And in order to do so, I need to deploy myself this counter. And since this is a compute optimization video, I'm gonna build that counter efficiently. Also because I'm cheap and I don't want to spend Sol on mainnet, so I want to be super small in my program size and also have low compute usage, might as well. So yeah, let's go. Actually, we do 3 counters. Let's do 3. One where we also optimize for compute units used. Okay? Good. Let's do it. Let's write another program. Cargo init. Pinocchio. A small counter program. So we need the lazy program entry point. Context. We get a maybe account. An account or a duplicate. Oh, that's cool. We assume account. That's nice. And then we borrow data mute. Actually, we can do everything unchecked. Oh, next account, that makes it mutable. Okay, yeah. Make it mutable such that you can do next account and then it changes the count. Yeah, that's fine. But I'll combine it with optimizations anyway. So that's my minimal program, which should be a working counter. Minimal, absolutely minimal. No checks. I don't care about security at this point. No allocator. And if I build SPF this, how big is that gonna be? I hope less than 1.6 kilobyte. 1.6 kilobyte is my target. 6 kilobytes! I don't want to pay for this. How did I build a program with 1 point something? And this was even with a regular program entry point. Okay. Do you think it will help if I make mine non-standard? Panic handler required. Hehehe. Standard panic handler. Now it's non-standard. How big is it now? Still 6.4. Still expensive. Like even such a tiny program, still 0.04. I mean, I could afford it, but can't I do smaller? If I wouldn't do that, it would be how big? Yeah, it's that line, and I don't think I can get around that. Although, can I not get around that? How about let's go even lower level. Look, I can make this so much more efficient. Hold on. The context points to, and yes, we're just gonna make this pointers now. What's inside this context? The input. Can I just work with the input directly? No, I can't access this input directly. Okay, can I not have the lazy program entry point? I want the buffer directly. Can I get the buffer directly? Because, I mean, this context also just points somewhere, and that somewhere should then have this as the first. So, can I have like a... But no, the raw pointer... I will write an assembly program if I need to. If I don't get to this stupid input here. I mean, that's what it gets. That's what it gets. Hold on. Since we're in a separate video where we talk about optimization, let's look into here. Okay, I can do that. I write my own entry point. Look at my own entry point. My program entry point. Really, I just need this. So I don't even need to define a macro. This is my program entry point now. Check this. We're not going to have an error. I'm not going to support errors. Forget that. But what if I want to have OK? I can't return the OK here. So that's probably 0. So I just return 0. Like a regular C function does in the beginning. So the OK would be return 0. Lower level coding here. And then we have this input pointer that I wanted. So great. Now I have this input pointer. Let me think where I need to write to. because I want to write into the first byte of the account data. So where would that be? The first 8 bytes are the number of accounts, which will be 1. Then there will be 1 account. It's not a duplicate, so I don't care about this, I don't care about this, I don't care about this, I don't care about this. But overall, this one 8 bytes, so that's 8 bytes, that's 8 bytes, another 32 bytes, 32. Then the account's owner pub key, plus 32. Number of Lamperts, and then number of bytes. So number of Lamperts, number of bytes. This should be 1. And then the bytes of the account. And then the padding. So this is the offset. And then I basically just, the whole function is unsafe, so I can do unsafe stuff. That's great. Then I just input at offset count up 1. Cannot mutate immutable variable input. I don't want to mutate that variable. I want to just write to that location. I did that once in the Pinocchio challenge. How about this? What I'm doing here is actually fun. I like this. Let's see if that actually works. Cargo build. I get a warning. Warnings are fine. Did you ever write your own entry point? I didn't until now. And now, look at that. My program is under a kilobyte. But does it work though? I still have my 48 sol from previous video. I'm first going to deploy it to DevNet. Should I already give it a different, small counter. Count speed. Yeah, that's gonna be my small counter. Copy, and then we Solana program deploy. 1 transaction. I can deploy this program in 1 transaction. Well, in 3, but I write the buffer in 1 transaction. Okay, but does it also work? That's the more interesting question here. That's why I deployed it to DevNet. That's the program. I can, create a random address. We call my program with a random address. And first we need to get the create account instruction to actually create that random address. 1 byte. Cool. Okay, let's see if we can call that. Use counter. That's the account. Success. Nice. Which means if I now Solana account this, I should have an account written 1 in it. My counter works. And if I now have this address and I'm not creating it anymore, use the counter account, count to 2. Count to 3, and the account should now be 3. Hehe. So the counter works. Look at that absolute minimum example of a counter program with less than a kilobyte. Wait, how expensive was it to deploy this? 0.001, and for the data account 0.007. So that's 0.008 or 0.01 essentially for the program. I guess I can afford that. Can I afford that? Nope. Just about not. Okay, fine. But that's just $1.50. I can afford it, okay? That's how much the program is gonna cost. Good, we tested the program. We can now totally deploy it to mainnet. So same thing as before, but this time to mainnet in 1 transaction. I love this. It's mainnet, it's slower. I also didn't set priority fees here. But it also works without priority fees, that's the thing. That's why I need this in the first place. So also on mainnet now, this program exists. It does exist. And I still have 0.001 sol. Okay, so far so good. See, I mean, being cheap is a good thing in this case because that makes me optimize my programs. I mean, this is hardcore optimization, isn't it? I mean, you can't do better than, can you? Maybe with assembly, but probably not significantly. Which also raises the question, actually, one such transaction that I just did on DevNet, if I increase the counter, takes how much compute? 5 compute units. It takes 5 compute units to increase the counter. So yes, I could do better probably by 1 or 2 compute units. But 5 compute units is already quite nice, especially considering how many I request. Okay, good. That's the setup. No, it's not quite the setup. I still need accounts for the counters, 3 of them. But no, actually, I want to change it. I want to change my program to just use 1 account. It's going to help me in the long run. Okay, I'm gonna change our program a little bit more because now I need instruction data as well. Okay, but we are here to build stuff. Basically, my idea is I don't want 3 accounts now for counting the 3 values. I basically want one account where I have 3 bytes for each of the individual ones, and which one I write to, I put as instruction data. That's the goal, and I want to still have it as efficient as here. So we're going to work with assumptions. We're going to work with the assumption that the account has a data size of 8, because that will help me A, not have to mess with like paddings, and B, in case I want more than 3, I have the chance to, you know, add some stuff. Actually, while we're at it, let's make it 16. Let's make it 16. The account will have a size of 16. That's my assumption, because otherwise I will need to read it. Or actually, I mean, I could read it. Not like I can't. I mean, it's literally there before the offset. Okay, fine, let's read it. Reading is better as having assumptions. Okay, so -1 in the offset. I mean -8, but we just read 1 byte, okay? It's not gonna, we assume that it's less than 256 bytes, okay? Good. This is just gonna be a byte. It's just gonna be a U8. I don't want to decode U32s because that takes compute. I ain't got time for that. I don't want to pay for that compute. We assume account is less than 256 bytes. Okay? Good. So we have the data size. So then we have offset plus 8 plus, we need an offset for the, how many is byte offset, how do you call that? Index is good. Assuming that index is 0, that should now basically do the same thing as before. We're not even using the data size. We use the data size to calculate the index, because the index is all the way at the end in my instruction data. So I will need to add all of this junk. So the data size, hold on, input at offset, by the way. That's the actual data size. Should I call this data offset? Input offset, input data offset, whatever, is the data offset plus 8 for the data plus the data length plus 10K, and that's actually 124. And then enough padding to align with 8 bytes. That's why I'm assuming it has 16 or 8 bytes. So we say ignore that. Then another 8 bytes of rent. And then I just provide one account. That's my next assumption. So many assumptions. 8 bytes of unsigned number of instruction data. We are also gonna ignore that and assume that we have 1 byte of instruction data. But yeah, then just another plus 8 and we're good. And then the index is input add input offset. But that's a mutable U8 pointer, so get me the U8. There we go. Oh, you're adding U8s together now? How the hell are you? Oh, no, this is not good. This shouldn't be a U8. Can I say you are a U size from the beginning? This is U size? Okay, will that work? We have no idea. I guess so. Do you know what I'm doing here? If you don't, I made a video on the entry point and that might help you understand stuff. Basically, I'm just working manually with offsets. You need to understand what that is. If you don't understand what that is, this gets very complicated. But in my head, it makes sense. And in my head, that will work. That will just work. Will it though? We'll see. We will see. Yeah, I'm actually reading the data length. I'm proud of myself that I don't just take that as an assumption. But yeah, it takes a bit more compute. But okay, I can afford that compute. Fine. If I were to build this, how much bigger is it gonna get? Not that much bigger. Okay, I want to redeploy to DevNet. Now, if I were to just use the counter program again now, it will crash most likely because I didn't provide input data. It doesn't crash. That's not a good sign. Although, well, it just writes into the padding. Wait, let's check that account. It's still, oh, it's 4. 4, and if I use the counter program, 5. The counter is still working. How is the counter still working? Yeah, because it reads index 0. Oh, that's fine. It just reads the... wait. Somewhere here, the index that it reads 0. Yeah, that's fine. Because I have 0... Wait, what's afterwards? Program ID. No, that's wrong. then stuff doesn't work. Obviously, I have a bug in my program, and this is gonna be difficult to debug. I have a bug in my program. It's not reading the right offset. Shit. My data offset is 1. Oh, that's why. I have a data offset of 1, and then I have a padding of 8. So we're reading somewhere in the size. Oh, that makes sense. We have 7 bytes too little now because my assumption that we have no padding is invalidated. We're reading somewhere in the data size now, the input data size. That's okay. Okay, so basically we need another account. So we create ourselves another account at a random address. This time use 16, so a multiple of 8. Okay, there we go. Now we have this account, the Gave. And if we put this one in here now, in here now, and don't create it anymore. For now, there should still be zeros. Right, we have 16 zeros. Now, if I do just that, it should actually fail in my opinion, because it should write somewhere completely different. Because now it should read the... I mean, it gives me a success. This is... And it still writes to the correct location. What the hell? As if I wouldn't have deployed the new version. And if I were to say data write to index 1, do you then change something or also write to index 0? No, you would also write to index 0. So you're certainly not reading that byte. Oh, I have an offset error. See, and that's the issue if you code on that level. Usually it's just the input data, get me the input data. But I refuse to go away from my highly optimized code here. Highly optimized, but not so readable version of this program. I'm pretty sure I just have an offset error somewhere. Man, but how am I gonna figure out my... Oh, am I stupid? 10K, it's 10K, not 1K. 10 times this. Well, that was my error. I was reading somewhere in the data for... Oh man, I could have figured that out. Oh man. You read 10K, you write 1K, of course. Okay, but now, yes, it's correctly reading my index, which is 1. And if I now check that account, it wrote to this spot. And if I say index 2 and I send that transaction, then it will also increase this one. This is how it works. Wonderful. Perfect. Okay. We can dump this again. Okay. Cool. Should we go back to mainnet with this version now? Yeah, with this version, we go back to mainnet now. Deploy to mainnet. No, we did not. That's what you get for not using a buffer account. But I think I didn't lose anything. So, okay, then let's use a buffer account. And there we go. It is deployed. Okay, good. We still have 0.01 sol. Still alive. Now, on mainnet, we create our counter account. This is going to be my counter account. So we just create an account here. Create counter account. We created this counter account. And now we can use it with our very efficiently implemented counter program. So now finally, for the actual testing. Level 0. The lowest possible priority that I can get. So, and in the end, we will always add this one. This is going to be my instruction to the program with the level here. So, and at level 0, I want to have the lowest possible priority. So I'm gonna get set compute limit 1.4 million. That's the maximum. Then I'm gonna add program instruction and that's it. So that's for level 0. For level 1, how about we're gonna keep the same, but now gonna add this one and we set the loaded account data size limit to the minimum that we can set it to, which is 22 plus 36 plus 37 plus 16, which is the size of my account. And then for level 2, let's also optimize for compute units. So in fact, let's test it once. Let's test level 0, just testing level 0. So that worked, just the base fee. We're not adding priority fees at all here. and it used 12 compute units. So the total was 162. Yeah. So in my optimized version, I can request 162. That's then for level 2. Let's run level 2. Computational budget exceeded. Oh, why? Oh, because I have another instruction to the compute budget program. So another 150. True. So it's 312. That's the absolute best the best priority I can get without priority fees. With priority fees, I get higher priority. But I don't want high priority. I just want to make the point that setting this actually makes a difference. So it also counted up this. To make them all the same, let's also do level 1, run it once, and now it's all 1. So that works. My counter program works. And those are the 3 things that I want to test. Once just with maximum compute units requested, then with maximum compute units but minimum data size limit, and then with minimum compute and minimum data size limit. Always without priority fees. Let's see if we can get a meaningful result by just running this a bunch of times. So how are we gonna do this? We are, for one, not gonna simulate stuff, not gonna confirm stuff, send it for 0, 1, 2, all of them at the same time. 1, 2, 3. Wow, it just does it, and then it doesn't check anything, but that's okay. If I now check that counter, none of them landed. Oh, hold on, did I not send it? Yeah, I'm signing, but I'm not sending. Hold on. I also deleted the actual sending. And now? There we go. I think they were sent. I'm not waiting for any results. Let's see. Yeah, they were sent. All of the counters went up. And if I run it again, 3 transactions, all of the counters went up. So, I mean, I can now basically just burn all of my Sol sending those transactions and then hope that some don't get sent or something. And if that doesn't work, I need to find a better strategy to test this. But now let's just burn through this 0.009 Sol. Make a loop while true. Let's see. I think this is, yeah, I thought so. I thought so. We are getting too many requests, but we're still didn't make a difference. So should we get a better RPC? I left this running while I had dinner. So a few transactions went through, but then a transaction simulation failed because this transaction has already been processed, which is odd. So I'm changing every single transaction, don't I? No, I don't. Problem was probably that after 10 seconds, it still had the same block hash, and then nothing else changed in the same level. But in any case, I don't expect that my counter is much different, like more than 1 maybe, because one of them failed. And no, they're still the same. 1, 1, 1. So we need a better strategy to make a distinction between those, to actually prove that priority means something. Because the primary goal of this video is to prove to you that this thing actually changes priority. And my secondary goal is to show you how I write efficient programs. Here it goes really for like performance over security. And that, like, for those programs, I mean, I have a counter. Who cares if somebody hacks my counter? I don't. So, you know, whatever. I'm investing as little money into this as possible, but I will need to improve it, I guess, if I want to prove that this priority actually makes a difference. Okay, so back to here. One more time, let's just send it once, such that we now have 32, 32, 32, 2, 2, 2, 2, 2. And then check out those 3 transactions. My question is, did they all land in the same block? Or can I see any other differences here? Block is 1, 4, 1. 1, 4, 1. 1, 4, 1. Okay, so here, no difference. They all landed in the same block. Okay, fine. Within this block, counter. 3 transactions in this block. All of them took 12 compute. We have the 452, 452. So they appear in the same sequence that they show up here. And is that also the same sequence 0, 1, 2, 0, 2? No, 0, 2, and then 1. But that's probably just because it sent that one faster. Like, it also printed it faster, so it sent it faster. Okay, how can I... Oh, I know. I mean, let me just go through a few ideas that I had. I could just say the first one of the slot, right? I save the slot and only the first one in the slot should return okay, the others should error. But then it probably comes down to which one I send first or which thread gets scheduled first here. If I don't really send them at the exact same time, I don't think I can get meaningful results here. Same with if I send 3 of them and only the first one increases the counter, the others should fail or something. That is pretty much the same, just that I don't need to save the slot, but save a number or whatever. And for both of that, I would need to change my program. But I just had another great idea. What if I make them more contested? Because if we have a look at in this block, all except votes, what are the programs that are called the most? I mean, token program, compute budget program, of course. But then we have this one, PAMM or Tube. Let's go with PAMM because everybody loves that. Problem is I actually don't know how that works. But if we look at such a transaction, basically, I'm trying to find accounts that are used a lot and are writable, because I can't, write lock the system program or whatever. What is this? This looks like it's being used a bunch. A few seconds ago, a minute ago. Nah, not that much. I'm looking for something like a fee address or whatever. This one looks like a fee address. This has a bunch of sol. This one is being used in most slots, actually. Look at that. This address is actually being used in most slots. Now, we don't know what it is. It's a wrapped sol mint account. Yeah, but who does it belong to? Do we care? Nah. This one as well. Look, the block, read-write count, total count, % of transactions. So obviously token program and those. And this and this. Is this also? Cheeto don't front run or whatever. It's fun to look at the block explorer once in a while. I'm interested in write. Many writes. This one maybe. Still all the same block. Oh, this is used a lot actually. This is really used in pretty much every block. And by a lot. So is that a program? What is this? It's not a program. It's a 0-byte account owned by the system program. Maybe an authority of some sort. Doesn't matter. 0 bytes is great because that doesn't mess with my calculations of the data that I need to load. How about this other one that I found? This is a wrapped sol account, so this will have the... Let's just try only this one. Let's just try this one account with 0. And what we do is we add it to our instruction, this contested address account role writable, such that the runtime can't schedule me, like this transaction can't get scheduled with another transaction that also has this account write locked or even readable because I want to write to it. So maybe that decreases my priority. Hopefully that decreases my priority. And since it's a 0-byte account and I don't do anything with that account, it should neither change my computes used or my data that I need, like my account's data size limit. So let's try that. Let's just run them once. Run. Send those 3 transactions and then check. None of them went through. Okay, good. We are back to none of them going through. No, wait, yes. Now it went through. It just literally now. What? With this one, it is writable. It did go through. Still 12 compute units. That's the 0 that went through even. But why does it then not increase my counter? I was already at 32. What? Wait, I know why. I know why. Because my offset of this instruction is now wrong. My offset for this instruction is now wrong because I work with the assumption, see so many assumptions, that I have 1 account and not 2. So my instruction data is off. But interestingly, it still works. It's not crashing, but it doesn't increase the counter. Okay, sure. Okay, fine. Back to you. This is so fun, always then debugging this. So I can't put this in here, obviously. But I could add instruction to the no-op program. I could change my program to fix that stuff, to ignore accounts, or I could even have a separate instruction on my program where it does nothing. Or I just do a separate one. Let's do instructions and get transfer sol instruction amount 0 destination this contested address source my payer, and then I flatten those instructions in here. So now I'm not only doing my instruction, I also transfer 0 Lampert to this contested address, but that makes it writable then. Then I need to have it writable in my addresses. So let's try that again. We're still at 32. We run the counter, we fail. Oh yeah, one of them will fail because I have the wrong... Oh, both! I have both, but the first one now goes up. Shit, the first one did go up. Okay, to fix that, because for one where I have the compute limit, I now need to add another 150 for this transfer. And for 2, I'm reading, wait, now I have, it's the system program. So I need another, what did we say, 22 bytes? No, what was the system program? 21 bytes. The other account has 0 bytes, so I think I get that for free. And the compute budget program I already have. So now it should work. Now let's just try 1 and 2. Can I send those 2? Yeah, now those 2 also work. And now my counter should be, oh no, look at that. That might be, it's not. No, it was just slower. It was just slower. It also went through. Okay, maybe I need to do a combination of all of those things, but we are at least getting somewhere. 3, 3, 3, 3. Let's do all of them again in 10 seconds intervals with this one account. Let's see, I let it do it, I don't know, 7 times or so. And then we evaluate. But hey, it's looking, at least it's looking like it's always the first one. Oh no, wow. Look at that though. Now we're getting somewhere. Not only is it the first one being updated, but it also at least already once was the only one. Wow, look at that. I guess that already kind of proves it. Woo, look, exciting. Exciting. It's finally working. Oh, it's catching up though. This one's catching up though. This one is just being thrown out. Oh no, BCD. No, they're all catching up now. Weird though. So oh, because I'm doing retries. That makes sense. Okay, stop it. DEF. Okay. DEF is the final count. The final countdown. Or count up, really. DEF. So we see what we expect to see, which is that the more priority, the higher the chance that this transaction actually lands. But it's just, it's a small difference. Once the one with the high priority through data size limit and through compute limit, once that went through when this one didn't, with just the data size limit. And that was once also better than setting none of them. Okay, so that's kind of what we expected, but it's still not as significant, I think, because I'm retrying. So when the transaction doesn't land, it tries to send it again, until it lands. We gotta stop that. When we send the transaction here, pretty sure I can have some more configs. Max retries, big int 0. So one thing, what else should I do? Skip pre-flight. And with those settings, it should get even more obvious. Oh wow, the one the one even still at some point made it. Actually, both of them. Eventually they made it because I kept retrying. Just to make sure that I can still do this, although just once. It does still go through. Now the counter is the same again. Right? Now we're starting at the same value. Let's run this with no retries and skip pre-flight. Let's go. 41. So all of them made it. 43. But we see that this one is usually the first to get persisted. And then the others catch up. It's the first one that gets in there. Then maybe this time the others don't catch up. this time all of them went through. So it also depends how many other transactions block that one account, because if none of them block that account, then my transactions just land as we had in the very beginning. Look, 47, 45, 45, and then 48, 45, 45. So this is already showing us something. This is already showing us that at least that setting the compute budget, the compute limit lower does make sense. Because here, this one is counting up, the others are not anymore. Oh wow, now this one is even counting up once and this one didn't match. This, however, is counterintuitive, but there was one time might just be down to luck, so that's not, I wouldn't, it could be because that landed at the validator first, because I'm sending this first usually. So, it doesn't mean much. But we do see, though, that this one is counting up faster. This one reached 5.0, whereas those are still at 4.6. So we can definitely say, and this is not chance anymore. Here, this one is definitely being accepted more often than the others, significantly more often. So the level 2 is significantly more often succeeding versus the other two. And the level 2, just to remind you, is the one where I set the minimum compute limit and set the minimum data size limit. So here we basically just see the main difference between this and that, which at least we prove that this is a thing. Setting the compute unit limit lower increases priority, but we knew that. At least now we also proved it. We mainly see the difference between those. We did not really see a difference between those, like not having this and having this. So maybe we need a different test for that now. How about... let's do another one. Let's do case 4, 5, and 6 or something. So let's say case 5 is same as above, the best possible without using priority fees, without paying extra. And, with using that little compute and having the data size limit that low. And I'm just gonna compare it to the same minimum compute unit limit, but not setting the data size limit. So in this case, it should actually also make a difference, because here, we're talking about 1 million CUs versus that, 1,400,000 almost difference, because the default of that is 16K. So it doesn't make that much of a difference. But this versus this, whether or not I have this, does make almost 16K in difference. 16K minus that times 8 divided by 32K. So basically 0. So basically it makes 16,000 compute units in difference. And the priority stays the same, or at least the priority that I pay, which is just my base fee in this case. So also here, I should see a difference. And now it's the same. It's a minimal compute. We optimized for compute unit, but in one time, we also optimize for loaded accounts, and in the other, we don't. Do you think we will see a difference? I hope so. So let's do 4 and 5. Let's run it. At the same time, also check that account. So now we're counting up those two values. They started at 0, they're now both at 1. And every 10 seconds, the first one even went through, and the second one also did. Okay, it just took a bit longer. So maybe this is not enough of a difference once again to really prove that it, maybe now all of them always go through because the priority is high enough again. Because with such low compute units, the priority is high enough, I guess, to compete with most other transactions, even without priority fees. Okay, so I'm afraid that I won't see a difference here. Nah. One more. So that doesn't, that's, even though, let's just double check, this account is still being used in pretty much every block, but my transactions just have such high priority because they are so optimized. And it's mainly about the compute optimization. And I can do that because, I run a transaction with 462 compute. This is not a lot compared to regular Solana transactions. Even if I don't pay priority fees, this will have quite some priority. So we're just gonna artificially pump it up again. So we're gonna do case 6 and 7, where we request a more, let's say, plausible, regular, more, something else. let's try the default 200k. Actually, the default would be 3 times 200k and 4 times 200k here because 200k per instruction. But I want it to be the same for both of them, so I'm setting it hard-coded. 200. Let's see if we see a difference. 6 and 7. Now we're counting up those two. And interesting enough, here, none of the two of them went through. Oh, nope. What? Did you see that? Wait, it showed me 1 and then it showed me 0? Hold on. Okay, no, now it's 1, 1. Yeah, apparently one of the RPCs that are queried was further ahead than the other one. But at least we see that this one tends to get it first. So either both don't get it or both get it. But I'm sending more transactions that actually land. Because here it still stays at 3. Now it's at 4. Now this one is at 5. So this one is the first one. And then the other one catches up. But then again, I'm sending transactions where none of the both of them get increased. So this doesn't seem to be a significant enough improvement that I see an actual difference here. So let's stop it. So maybe 200 is too high. Well, then let's do 16k and 16k. This should again be at least, you know, better priority. Let's run this and see how that goes. 7677. Okay, now they're always going through again, but I still can't prove that adding this makes a difference. I want to be able to prove this. So this is my goal. That's my primary goal that I managed to do. This is the entire video here. How can I prove this? I'm not out of ideas. I will find a way. Okay, so I already quite like this with the setup of having this account here. But now maybe let's really do the one that does it first gets to call it, kind of. And there are several ways how I could do that, either with that actual transfer, but I think the cost efficient way, let's add something to my program. Why am I doing this to myself? I basically want to say, hey, from those two transactions that are the same, only the first one should be able to write. So I give you a number, and for that number, only the first transaction gets to execute successfully. The others return an error. First, let's read the, what are we gonna call it? The batch. Let's call it batch. The batch will be this, just the next byte. So right after we read the index, so it's another part of input data. I put the batch number as input data and the UA should be enough. That's fine. And then if, wait, we first need to read the existing batch. Let's call it compare, which is basically it's gotta be somewhere in the account. So at index, should we say 15, the last byte of a 16-byte account, or should we use the first byte? Now let's use the last byte in the 16 account. That's why we compare with. And then if the batch is not the same as the compare, then we can do this. So we increase the counter and write the batch, should I call it, at that compare offset will be the batch. We write that byte there. Then we return 0. So that's my okay. Else, or you know, here, we return an error. And I don't know, like, I don't have the error mapping. I don't know which error I'm actually, I would need to look at the error enum, but I'll return whatever is the first error. Whatever, it's gonna be fine. Anything that is not 0 is an error. So, you know, just anything. Cool. Are we good with that? I think I'm good with that. Yeah. I don't need to test with DevNet. This is gonna work. Cargo, build. We're above 1 kilobyte and we deploy with this buffer. Yeah, insufficient funds, I thought so. Dang it, I have 8.4 and I need, what? I need 8.3? So close. Then I don't have enough for rent exemption. So I have enough for this and the fee, but then not for rent exemption anymore. That's just ridiculous. Okay, fine. Another $1. Okay, fine. Fine, have another $1.6. Stop annoying me. Can we deploy? Yes, we can. So now we gotta change our script here a bit. First of all, and just to test, let's get rid of this. We say the level and 0, and then the accounts didn't change. Let's just do number 7 once, just to see that this should actually fail now. See? It failed. Why did it fail? Oh, it's custom program error. Maybe the low numbers are the custom programs and negative numbers are the Solana internal ones. Custom program error 0x1. Great. I return 1. I consumed 8 compute units because 0. Why? Well, if we have a look at the account, I'm comparing to this byte. And if it's the same as this one, then I make the transaction fail. So that works. That's cool. Because if I now do, just for a quick test, let's say level is 14 and my number is FF, then that should land. Now it goes through with success and it takes 18 compute units plus those 2. Instead of 12, I now need 18 compute units. But if we now check the account, this one, because I randomly set to 15, went up and FF is written in here. That's what I'm comparing to. So program seems to work. That's good. Back to those. Now let's do this thing with this other account that is used a lot. Level here and batch, which is a number. Batch here. Then the actual min compute is now 18 plus 3 times 150. Because this is what my program takes, and then 3 times system program and compute budget. So let's do with 6 and 7 again. Make a let I be 0 and put the I in here. There we go. And maybe I just wait 5 seconds. So let's run it. So I think now only the second one went through because the other one must not. Now it can only ever be one of them. Now only one can be increased. Is it the first one or the second one? Or none of them? Hey, but here I think we see that the... Nope. What? D and F. Nah, not always. Not always. The second... difficult to say still. I'm querying different RPCs with completely different values. So let's just do it a bunch and then let's just wait. Let it do it a bunch. Hold on. Check it. I mean, it seems like now the second one is 7 times more. And where did I start? At 0 something. So almost double as often do I get this one as the first one. And let's just double check my account. Yeah, that's what it should look like. There should be 1 success and 1 failed. 1 success and 1 failed. Sometimes I'm getting more successes. I think that's because the 3 seconds is not enough and then takes the other one. Like if there's this one, then and then from the previous one. So to make really sure that it's always just one of the two, I'm gonna wait 10 seconds again. And you know what? Let's do it again with those two. Do again with 5 and 4. Let's see if we see a difference here. At 5 and 4, just to reiterate, we have the minimal compute for both of them. Once without and once with the setLoadedAccountsDataSizeLimit. So now we're comparing those two again. Look in here. Let's run this. Now, here this one was first. It's a 2. You can also see the current batch. 3, then this one was first again. At 4, the first one was first. So it's not 100%. We're back to 3, back to 4, back to 5. Now the second one again. 6, again, second one. So more often than not is the second one. So the one with the lower data size limit, the one that is first, which means it has higher priority. So it seems like it actually, wow, it's catching up again. But only because I'm sending it first as well. It's catching up again. Oh, this is again, kind of looks like more, now it looks like more like chance. Not sure anymore. I'm getting old states depending on which RPC serves me the data. It's fun. What I should do is have a subscription for this account and print me the updates for this account. Should I do that? So it's at 10 and 20. So we have 16 more calls for this one than for this one. And we already started out at 0A. So now I'm somewhat confident again that the chance for the second transaction to land is actually higher than the one for the first. And most likely the only reason why it is first is because this one gets scheduled first. Slightly earlier than this one. And even for that, I can make a kind of a blindfold test. That's the last thing that I'll do. So let's do that. Let's do the same as 4 and 5, just with 8, 9, 10, and 11. But the ones in the middle will set the data size limit. The ones outside will not. So 8 and 11 will not, 9 and 10 will, and I will call them in the order of 8, 9, 10, 11. It's still down to luck which one gets scheduled first, but I would tend to think that this has a slightly higher chance of being first, like hitting the RPC first. Let's do that. And also, I want to build myself an observer script. How did that go again? Account notifications for counter account address. Subscribe. There was something with, how did I do this? I did this once. In which video did I subscribe to changes? Oh yeah, that thing that I will just not ever. Symbol async iterator. We get this iterator and then get the result. If the result is done, we return. And then, so this should be an account notification. Decode, or was it encode? I never get those. Data bytes. Console log account data bytes. Let's try this. So here, instead of manually always querying this account, I'm gonna observe the counter account. Okay, that seems to maybe work. And then I run this counter. Now with, 8, 9, 10, 11. Let's see. Pumping transactions. I don't see shit here. Check the account manually. I mean, so far so good. That's kind of what I would expect, that the inner ones get more than the outer ones. But my observing doesn't work. Oh, my RPC, well, that explains it. My RPC subscriptions were on DevNet. Oh, no wonder I couldn't confirm transactions. That's why I had my RPC subscription set to. Okay, all good. Just try this again. Yeah, that's better. Okay, so basically those are the 4 bytes that I'm interested in. The ones in the middle are the ones with a high priority. The ones on the sides are the ones with a low priority. This is my batch number. And we see with every batch number, it's just updated once. So even though I sent 4 transactions, only one of them makes it. We can also look at that here. If we refresh, then we see 3 failed transactions for every successful one. So that's working. My batching is working. Well, batch. Is it a batch? Yeah, it's a batch, but with the idea that only one of the batch should actually go through. It's still a batch. Usually batch is used for we put them together and all of them should work, but no, not in my case. I want only one of them to succeed. So yeah, this seems to be working. So keep running that counter. Interestingly, this one sometimes manages. So maybe the last one is actually scheduled more often. Maybe it's also the last one hitting the validator that it takes if it's the same priority kind of. First one definitely is sucking against it. But yeah, I mean, with some confidence I can say that those numbers, the ones in the middle, are higher than the ones outside. It can still be up to luck, but I would say that it's getting somewhat statistically significant that those are higher. I'm just gonna send another 4 times 100 transactions and see what happens. I could add priority fees and be like, see, with priority fees, it makes a difference. But it's already enough to see requesting fewer computes also makes a difference, even with no priority fees. So you don't need to set higher priority fees to increase your priority. That's the whole point of this video as well, and the previous one. We can increase the priority simply by setting lower compute limits and requesting a lower limit for account data size. We stopped. Yeah, we stop at 100. That's true. But I mean, you be the judge, but I think that those 2 numbers are higher than those 2. The sum definitely is. Here, the difference between those 2 is not big enough that I would say like, oh, for sure, but it's the total that counts anyway. And then I would be like, 18 plus 26 is definitely smaller than 35. Well, actually, let's calculate that. 18 plus 26, 44. 35 plus 51, 86. So that's double. That is double the transactions that went through when we were setting this lower limit for data size versus when we were not. And the rest was all the same. So, and it's not, no, okay, let me rephrase that. It's not that they went through, they were processed first. All of them went through, or most of them at least I would say went through. But some of them I made fail because I'm just accepting the first one of the batch. And in this case, twice as many were processed first with setting this lower limit for accounts data size. Loaded accounts data size. So in this test, I'm somewhat confident to say that this does make a difference in priority. Answer is not bullshitting us. That actually does make a difference. And we managed to actually prove it. So that's cool. Yeah. I mean, if you don't believe me, try it out yourself. You don't need to believe me, obviously. Often I don't even believe myself. So that's fair. But I tried to make a good point here with actual experiments on mainnet, just trying it out, and it looks like this actually does make a difference. So next time you really want to have a high priority transaction, instead of overpaying priority fees, maybe you want to do that and set the data size limit for your account a bit lower. Right, to recap, what did we learn today in this video? I mean, this was the learning from the previous video basically, and now in this video we proved it. We managed to have a setup how we can actually test it by adding an account to our transaction that is often written to and therefore will be put into one of the buckets where transaction priority then actually matters. Because the cool thing about this fee model is actually that accounts that are not used a lot don't need to pay for high priority, even if somewhere else there is a hotspot of, you need to pay a lot of priority to get your transaction through. So just because pump fun is pumping or whatever, or there's a hot mint or whatever, you don't need to pay higher fees for just sending some sol or calling your random program. And that's what we see here. So we artificially made it difficult for us by including this account, such that we can see a difference when actually comparing different compute unit limits and different limits for the loaded account data size. What else did we learn, or what else did we see in this video? I wrote a program that is somewhat CU efficient and also, small in program size by writing my own entry point. Because I can. I mean, this is getting close to, this is very close to what I would do in C. I mean, it's literally, this is basically C code. And it's also very similar to what I would do in assembly. I could probably read the assembly code of this program. If you want to learn how to read assembly code, I'm gonna send you right here, this one. This one, this one, here. Here, I'm gonna put the video right here, where we disassemble Solana programs. And here's another video that you might want to watch. And then give this one a like, subscribe if you still haven't done that. Let me know if you like these kinds of videos. This was more an experimental, hey, what can we do kind of a thing? And basically just me playing around with writing programs on a pretty high level actually. So don't worry if you didn't understand what I was doing back here. This is pretty high level. But if you do understand it, and if you are on that level, then it's super fun. I had fun doing this. So yeah, please do let me know in the comments or on X or wherever you can reach me, which admittedly is difficult. Do let me know if those sort of videos are helpful or not. I hope that at least some of you were curious how I do things and could also follow all of that. So if you're one of those people, you can look forward to my next videos. 'Cause I enjoy that stuff.